Let's move on to our next step. In this lecture, we'll focus on creating this transaction pool. Let's say person A wants to send cryptocurrency to person B. The value of this transaction is 1.0. In this case, this address here will be the address of the sender, or person A. The recipient, or person B in this case, will be identified with this blockchain address. In this pool, we have one transaction with value 1.0, and then if person A sends cryptocurrency with value 2.0 now to person B, then we have a total of 2 transactions in our pool. Now that we understand the concept of transaction pool, from now let's write the code for creating this. Now back to our code. We'll scroll all the way up to the top, and if you recall last time, we inserted last block. This time let's scroll down and start from after printf. You can start from anywhere, but I want to create a blank workspace, so let me press enter and start from here. For this, we'll enter type transaction and create our struct first. Let's add our sender's blockchain address here. That will be a string. Next will be recipient blockchain address, so we're referring to the recipient's blockchain address. On the next line, we'll have value. For this, let's enter float 32. And this is how we completed the fields for our transaction. Next, let's code a function for creating transactions. We'll say new transactions, and string for sender, and string for recipient as well. Next, we'll have value float 32. And now we've created a function with this argument. Regarding our return value, this will be transaction. We'll return, and this is simply just transaction with sender, recipient, and value. This time, we didn't include new, but the code will work with this. So let's try it with this style. Now that we've gotten this far, let's include a method to print this. We could write strings here and override, but let's make this easier to understand by saying print method. And then we'll write fmt printf and %s, and then a new line. Then strings repeat and include 40 hyphens before printing out our results. We're including this step because there are multiple transactions within our pool. We'll be using loops to display all the transactions, but it will be easier to look at the transactions if they're separated out. Next, we'll include fmt printf, and this time we'll enter one space and then sender blockchain address. Let's include some spaces here, and then %s new line, then t sender blockchain address. Let's copy this one line and paste down below. And this time, instead of sender, we'll rewrite this to recipient. Same with the latter part, we'll rewrite sender to recipient. These are simple lines to print the sender and recipient's blockchain address. And last, we'll enter a line for value. This is a float, so we'll rewrite this to %.1f. This is how we'll display our float. And this will be easier to understand after you run our code in case you're a little confused. Here, we want to refer to one decimal point, so that's why we're going to write this section as 1.0. Instead of numbers like 1.000 or similar numbers with many decimal points, we're only going to be printing values like 1.0 or 2.0. Numbers like 2.0000 would not be displayed. That's what this means, and later on we'll be marshalling. So we're going to go ahead right now and write the function. We'll be writing transaction, then marshal JSON. This is going to be a review of what we previously learned. We'll include byte and error, and this is how we're going to override our method. Then return JSON marshal and struct. After this, we're going to take these 3 lines and copy and paste down here. And here, if this is lowercase, we can't marshal, so we have to change this to uppercase. Then we include JSON and specify how we want our string to be displayed for marshalling, so we'll write sender blockchain address. And then for the second one, we'll write JSON recipient blockchain address. And then for this line, we'll write JSON value. And regarding this struct, we'll only be using this while we marshal. So if you want to make this look simpler, you could delete this blockchain address portion. This is fine too, if you think this is not needed. And inside value, we'll have sender. And in this field, we'll store T sender blockchain address, and for the recipient, we'll store T recipient blockchain address. And then in value, we'll store T value. This struct portion is created just for marshalling purpose. The exact words used here aren't that important. What's important is that the fields start with capital letters to make it public properties. And how you want it to be displayed is also an important part. So these are the parts that are important. We just created a custom JSON Marshall struct. What I just covered may be covered in an introduction course, so maybe this portion is review for some of you. For our next step, we'll be creating a method to take this transaction and adding them into our pool by adding on a method to our blockchain struct. Now this time, we'll be scrolling up and going to the top section of our code. If you recall, we had a section where we identified the transaction within the block. Let's scroll a little up. We're going to be looking at this block, then this transactions. We hadn't defined this transactions, so that's why we simply wrote string. We'll rewrite this now and change this to a slice where we'll include the pointer for the transaction we just created. Then for this argument, we'll include transactions, then pass in the slice of our pointer for transactions. So this is how this should look. Next, we'll include B transactions and store transactions. When we return new block, we'll be able to rewrite it. And the transactions that's located within the block, let's delete this. And here, we want to run a loop. We'll say for, and we won't be using index, so T. Then range B transactions, and we'll run our loop like so. And for our transactions, we had print, so we'll simply call on that. Then let's scroll down and refer to this Marshall JSON section. Right now, we see that there's an error. Why is that? That's because this is a string and we need to rewrite it to transaction. On my screen right now, the codes aren't formatted, but if you want, you could use a function in Go and format these lines. I'm manually formatting the lines right now. It's up to you if you want to make this section visually organized or not. Now we're going to look at this blockchain struct, which is down below. We have string inside transaction pool, but let's change this to transaction. And then, going further down, we have an error here for our create block as well. So regarding this section, this is just an example, but let's say that we have two transactions inside our pool. We want to take these transactions that are inside our pool and store them in this block right here that we see on the right. Once that's done, we want to empty out our pool. Right now, we don't have any transaction data, but we'll write BC transaction pool and create a block with this. After this, we'll empty our BC transaction pool. So that's why we're going to write like so. We're creating this section right now, and it may be difficult to really understand this completely, but please bear with me for now. We'll get into this a little more later on. Once this is done, we'll take this blockchain struct and add on another method. This time we'll say func BC blockchain and add transaction. We have this transaction down below, and we want to store this into our blockchain struct. For our argument, first it's sender string, then recipient string, followed by value float 32. Then for our next line, we'll write T, then new transaction with sender, recipient, and value. We'll create this transaction, and once that's done, then we'll have BC transaction pool. So the transaction pool for the blockchain will append and store BC transaction pool, then T. Then when we call add transaction, this might be a little small to see on the right, but you can add transactions. Now that we've gotten this far, we want to use this add transaction to add transactions, so we'll go back to our main. Let's scroll down and then bring main to the center of our screen. Now, inside here, we're going to use add transactions. For this, we'll write blockchain add transaction. For example, let's say sender is person A and recipient is person B. Our value would be 1.0. Now let's run our code. And when we do, we see that this transaction that we added here of AB 1.0 is added here. This chain 0 is the first. Then the next chain is chain 1, and here we printed it out with the transaction added. The AB 1.0 transaction is displayed here. Then in chain 2, we don't have any transactions, so let's add a transaction. We'll copy and paste our already made transaction, and let's display 2 transactions. This time, let's say person C is sending to person D, and the value is 2.0. Then person X is going to send to person Y, and the value will be 3.0. Let's run our code with this. When we do, we have our last block displayed here, and we see the transactions that we just created displayed here. This is a transaction with person C and D. The next one is a transaction with person X and Y. Now inside our third block and in transactions, we just created 2 transactions. We've learned how to create data structure for our transactions, and now let's review what we just learned. We have blockchain and add transaction. Let's look at what's stored inside it, and I'll just type Command B since that's the shortcut I created. At this point of add transaction, person A is sending person B cryptocurrency with value 1.0. That's our transaction. We have here BC transaction pool, and this transaction is stored in this transaction pool. Now we're going to go back to our main, and we just went over add transaction, and next we created a hash. Our next line is blockchain create block. Let's look into this further. I'm going to do Command B since that's the shortcut. And once we create block and go inside it, then at this point, when we create a new block, we're putting in the data in the transaction pool and creating this block, just like this visual here. After adding this block, then we use append to add it to our blockchain. Then with our BC transaction pool line, we're emptying the data from our transaction pool. Later on, new transactions will be stored in this transaction pool. This may all sound confusing, but please review the code that you just wrote now, and hopefully you get a better understanding of all of this.